If you've ever studied 3D geometry, you've probably seen a sphere before. A sphere is essentially like a circle in 3 dimensions. It's a 3D analog of the 2D circle. And an ellipsoid is something that's very, very similar to that. As you can see from these examples over here, it's got a very similar type of shape, except it's elongated in different directions. And the way we can determine how it's elongated is with these denominators. So if you recognize the equation of an ellipse, which is usually x squared over a squared plus y squared over b squared equals 1, the a squared and the b squared correspond to a and b, which are the semi-minor and semi-major axes. And over here you've got a similar story, except now it's in 3 dimensions, right? The main difference between this and a sphere is that the distances from the center to each of the sides are not the same necessarily. In a sphere it's one uniform radius. Over here it's not the case. But you might come across the question of how to calculate the volume of an ellipsoid, because remember, with 3D you can calculate the surface area, but more important than that often is finding the volume, how much space you take up. And it's relatively straightforward to do that with a sphere. You might not know the proof for the formula, but you might know the formula itself, which is 4/3 pi r cubed. But how could you do the same thing with an ellipsoid? Just like an ellipse has the area formula pi times AB, so where A is one of the radii, I guess, and B is the other one. A circle has pi r squared. An ellipsoid takes on the same form. It's ABC, so that would be like, instead of the radius, which gives you r cubed, you have ABC, and then you've got 4/3 pi in front. So that's the same formula. But what's more interesting than knowing the formula is knowing how that comes about. If you're interested in seeing a proof of that using calculus, using some integration and such, comment down below and I'll make one soon. Thank you for watching.